In this lesson, we'll talk about decomposition reactions and how we can predict what the products are going to be when a compound decomposes. So recall that a decomposition reaction is when a compound breaks down into two or more simpler compounds or elements. And it can be represented in a generic sense as AB breaking down into A plus B. And AB can be various types of compounds, and A and B can either be elements or compounds. So we're going to look at 4 different types of decomposition reactions. So the first one being a binary compound decomposing into its elements. The second one, a metal nitrate decomposing into a metal nitrite and oxygen gas. Third, a metal carbonate decomposing into a metal oxide and carbon dioxide. And fourth, a metal hydroxide decomposing into a metal oxide and water. So we'll look at each of those individually. So the first one, when we have a binary compound decomposing into its elements. So how do we predict products of simple decomposition reactions when you're given a binary compound and it's breaking down into its elements? So first, you're going to determine which 2 elements are present in the compound, and those are going to be your products. Remember that the majority of elements are monoatomic. However, you have to remember the Hofbrinkel elements, which are diatomic. Then you're going to balance the equation. So let's look at an example. Lithium oxide is going to break down into its elements lithium and oxygen. So lithium is monoatomic, and oxygen is a Hofbrinkel element, so it has a subscript of 2. Okay, then we need to balance, so we need 2 oxygens on the reactant side, and then 4 lithium on the product side. Another example, potassium iodide, going to break down into potassium and iodine. Iodine being a Hofbrinkel element, so needing a subscript of 2. Then we're going to balance, so we need 2 iodine on the reactant side, and now we need 2 potassium on the product side. So that is how we predict products of decomposition reactions where we have a binary compound just breaking down into its elements. The next one was the metal nitrate decomposition. So here we're starting to deal with compounds that have more than 2 elements, so not binary compounds. So if you have something with more than 2 elements, they're not usually going to decompose into all their individual elements. Instead, they're going to break down into some combination of compounds and elements. So specifically, metal nitrates decompose into the metal nitrite and oxygen gas. And so recall that the nitrite ion has 1 less oxygen atom than the nitrate ion. So let's look at some examples. So sodium nitrate is going to break down into sodium nitrite. So we're going to just take off an oxygen and oxygen gas. Okay, then it just comes down to balancing, which we can do by adding those 2s. Looking at the next example, magnesium nitrate. So again, we're going to just remove an oxygen to make magnesium nitrite plus oxygen gas. And in this case, this one is already balanced. Okay, the next type are metal carbonates. So metal carbonates decompose into the metal oxide and carbon dioxide. So let's look at some examples. So calcium carbonate. So we're going to do calcium oxide. So at this point, you want to remember how to create ionic compounds. So we've got calcium ions and oxygen ions. They're going to cross over. So calcium oxide looks like this, CaO, and carbon dioxide. And this one is already balanced. Another example, aluminum carbonate. So we're going to create aluminum oxide, Al3 plus and O2 minus, cross them over. So Al2O3, aluminum oxide, plus carbon dioxide. This one needs a bit of balancing, so we put a 3 in front of CO2, and then we're done. Okay, the last kind we're going to look at are the metal hydroxides. When they decompose, they again make a metal oxide, but this time with water, right? Whereas the metal carbonates had a carbon, so they make carbon dioxide. Metal hydroxides have a hydrogen, so they're going to make water, H2O. So looking at this example, calcium hydroxide. So again, we're going to have calcium oxide. So you do your crossover like we did on the previous slide, CaO plus water. And this one is already balanced. One more example, sodium hydroxide. So now we've got sodium with a charge of +1, oxygen 2-, cross them over, Na2O plus H2O. This one is not balanced. Okay, we need 2 sodium, and then we're good to go. So those are the 4 different types of decomposition reactions you'll need to be able to identify and predict the products for.